Hello everyone. Audio video is clear to everyone? Audio video is clear, just confirm. Audio video is clear everyone? Just confirm me once. Please check for audio and video. Is it clear? So a very good evening everyone. I welcome you all to the YouTube platform of IMS Gate Academy. We are conducting the Gate Score Booster series to help you revise the entire subject in just a span of 6 hours. My dear students, myself Prateek Mishra, and I will going to discuss complete syllabus of environmental engineering today and tomorrow. First of all, I would like to tell you, environment is one of the very highly weighted subject for your GATE examination, especially for civil engineering students. If they want to appear second paper from environment, again environment becomes a very important segment. Okay. Now, first of all, environment has a weightage of 10 to 15 marks, and the question asked from the environment can be framed of multiple choice variety, multiple select variety, and also from numerical answer type question. Means environment has a scope of framing of all the varieties of questions. Okay, that's why this is one of the very easy and one of the very important subject for GATE examination. Okay, now most of the students have doubt. They understand the concept, but the application part is lagging somewhere. So today I am going to deal with all those doubts that students regularly faces. So before starting this session, I have to make few announcements. First announcement, my dear student, is in our Telegram group, we regularly post all the job notifications and vacancies that are available to you throughout the year. So you can join our Telegram group. The link is provided in the description box. If you want to enjoy the taste of daily quizzes, again, you can join our Telegram group. So these two things majorly we provide, and we also provide you with the schedule of our YouTube sessions. So you can avail all these facilities by joining our Telegram group. The next announcement is, my dear students, we at IMS Gate Academy provide you with 3 or 4 different types of courses. First one is our live online program. Second one is our classroom program. Third one is our hybrid program, where the students enjoy the fusion of both online and offline teaching. Last one is our self-learning program. Okay. In all these programs, we provide you with 800 hours of live teaching along with live interaction for doubt solving. We give you more than 30 plus theory and exercise books so that the student can practice all the concepts and numericals using our textbooks. Next, we provide you with 12 one-to-one mentoring sessions. My dear students, this is one of the game-changing thing that we provide at IMS Gate Academy. We take care personally for all our students. If they have any doubt regarding their preparation, regarding their planning, that is where these My Plan sessions come into play, and these are like a game-changer thing, especially when I talk about the hectic journey of GATE preparation for 8 months. We provide you with 130 plus online tests. In our test, we provide you with chapter test, subject test, multiple subject test, advanced subject test, full length mock test, along with the video solutions, and where you will enjoy all the 3 varieties of questions that are asked in GATE examination. It can be multiple choice question, multiple select question, or numerical answer type question. So these are few of the announcements that I have to make before starting my session. So let's start the very beautiful subject of environmental engineering. So what we will going to do is, first we will going to discuss the basics of the concepts, and then we will going to solve questions, right? In today's session, we will going to cover the first half of environmental engineering. If I talk about the complete syllabus of environmental engineering, it comprises of raw water engineering, wastewater engineering, air pollution, and solid waste management. So today we will going to discuss all the aspects of raw water engineering. My dear students, raw water engineering is the engineering related with collecting water from the source, analyzing this water, treating this water, and supplying it to the community. This engineering is classified as raw water engineering. First, if you want to supply water to the community, the first thing you should know how much water is required in the community. So the first topic of discussion is water demand. For calculating this water demand, you need to know the population of the community. So for that, we have a topic of population forecasting. Once you know the water demand by analyzing the population of the community, then you collect water from the source. And after collecting water from the source, you need to analyze this water using water quality parameters, whether this water is suitable or not, or whether how much amount of treatment is required for this water. So the next topic of discussion is sources of water and water quality parameters. After analyzing this water, we need to treat this water. Then comes the topic of treatment of raw water. Once we have treated this water is stored in the service reservoirs from where it is supplied into the community using the water distribution system. So then we have the topics of service reservoir and water distribution system. So this is the flow of your raw water engineering. Especially my dear students in environmental engineering, this flow is very important to remember the things or retain the formulas for longer duration. If you remember the flow, you exactly know which type of problems you are dealing with. So this flow is very important. Water demand, population forecasting, sources of water, quality characteristics of raw water, then treatment of raw water, service reservoir, and then you have the water distribution system. So let's start one by one with the very first topic of water demand. My dear students, water demand is the total quantity of water required in the community. The total quantity of water required in the community is termed as annual draft. I'll keep writing it. The total quantity of water required in a community in 1 year is termed as annual draft. Annual draft or annual demand. The total quantity of water required in a community is termed as annual draft or annual demand. Now, the second quantity is annual average daily draft. Annual average daily draft is the total quantity of water required in a community in 1 day. Annual average daily draft or daily demand. This is the total quantity of water required in a community in 1 day, and this is equal to total volume of water required in 1 year divided by 365. The next quantity required for calculating the water demand is annual average per capita daily draft. So annual average, as the name says, annual average, as the name says, annual average per capita daily draft. Annual average per capita daily draft or demand. Annual average per capita daily draft or demand is the total quantity of water required in a community by one person in 1 day, and this is equal to total volume of water required in a community divided by 365 divided by the population of the community. Here P is the population of the community. P is the population of the community. P is the population of the community, right? So before designing any raw water scheme, first you need to know what is the total quantity of water required. The total quantity of water required in a community in 1 year is termed as annual draft. The total quantity of water required in a community in 1 day is known as annual average daily draft. The total quantity of water required by one person in 1 day is known as annual average per capita daily draft, right? Now this total water demand comprises of these water demands. The total water demand comprises of these water demands. The total water demand includes the domestic demand. Domestic demand means the quantity of water required for domestic uses like kitchen, bathing, washing, etc. Right? So the quantity of water required for domestic use is termed as domestic demand. Value can be 135 to 225 LPCD. Second is your industrial demand. Industrial demand is the quantity of water required in a community by the industries. that is classified as industrial demand. It varies from 50 to 450 liters per capita per day. Now it depends what is the extent of industrialization, how many industries are present. More the number of industries are present, more will be your industrial demand, right? Next is, third one is your institutional demand. Institutional demand is the total quantity of water required by the different institutes of the community. Now what are the different institutes? Different institutes may include colleges, schools, government offices. All these are the institutes of the community. The quantity of water required by the different institutes of the community is termed as the institutional demand. The value can be 20 to 50 liters per capita per day. The next one is water for public use. Now this is the water which is required for road cleaning purposes. This is the water which is required for gardening the public gardens. Right, so this is that part of total demand which is required for public use. So fourth one is water for public use, range is 10 to 20 LPCD. Next one is your fire demand. Now this is very simple. Fire demand is the total quantity of water required in the community for firefighting. If there is any fire outbreak, then the amount of water required is termed as fire demand. This fire demand can be either taken as one or can be calculated by using the different empirical formulas. We have the different empirical formulas for calculating the fire demand that we will going to see just now. Last one is thefts and losses, right? Now, when we supply this water to the community, due to leakages, right, or due to illegal connections, so much amount of water is lost or so much amount of water is not accounted. So that water comes under thefts and losses. So that part of water which is either lost due to leakages or that part of water which is not accounted due to illegal connection, that comes under thefts or losses. This total water is equal to the water demand of the community. So I have just classified the water demand based on the different usages. So total water demand comprises of domestic demand, industrial demand, institutional demand, water for public use, and last one is fire demand, and after that you have thefts and losses, right? Now next thing is, what are the different empirical formulas to calculate the fire demand? So we have different empirical formulas. I have listed all of them. First one is, in every empirical formula, my dear student, you should keep a check in which units you are substituting the values and in which unit you are getting the answer. Because empirical formulas are first of all derived for a particular set of conditions, and for that particular set of conditions, the units in which we have to substitute the values, those are fixed. So we need to keep a check in which unit we need to substitute the value and in which unit we are getting the answer. So fire demand first of all can be calculated as per Government of India manual formula. Using that formula we can calculate fire demand is equals to 100 root P, where the fire demand is obtained in kiloliters. We obtain the volume of the fire demand. What we obtain? We obtain the volume of the fire demand, and here this population is kept in thousands. So if your population of the community is 1 lakh, say if your population of the community is 1 lakh, right, then the value of P will be 100, because P is substituted as 100 thousands. Here population is substituted in thousands, right? So the first formula for calculating the fire demand is Government of India manual formula, and as per Government of India manual formula, fire demand is equal to 100 root P, and here P is the population of the community in thousands, and we get the fire demand in kiloliters. The next one is your Cushling's formula, which says that fire demand Q is equals to 3182 root P. Fire demand Q is equals to 3182 root P, and here we get the discharge. We get the fire demand in the form of the discharge in liter per minute. Units are very important, my dear students. Please keep a check on the units. Through Cushling's formula, the fire demand is equals to 3182 root P, and here the fire demand comes out in liters per minute, and again the population P is kept in thousands. The value of P kept in thousands, right? Next one. Next we have the Freeman's formula, which says that fire demand Q is equals to 1136 P by 10 plus 10. Here also the fire demand is calculated in liters per minute. Fire demand is obtained in liters per minute, and P is again the population of the community in thousands. Next one, my dear students, as per National Board of Fire Underwriters method, if the population of the community, very important, very important, If the population of the community is less than 2 lakhs, then fire demand Q is equals to 4637 root P into 1 minus 0.01 root P. And again the fire demand obtained is in liters per minute, and the population of the community is again substituted in thousands, right? So as per National Board of Fire Underwriters method, if the population of the community is 2 lakhs, then fire demand Q is equals to 4637 root P into 1 minus 0.01 root P, and fire demand is again calculated in liters per minute, and your P is the population of the community in thousands. If your population of the community is more than 2 lakh, please keep a check, never make a mistake here. If the population of the community is more than 2 lakh, then as per National Board of Fire Underwriters method, the fire demand is equals to 5400 liters per minute for first fire and 9100 to 36400 liters per minute for the second fire. So as per National Board of Fire Underwriters method, we have two relations if the population is less than 2 lakh or more than 2 lakh. If it is less than 2 lakh, first relation. If it is more than 2 lakh, then for first fire 5400 liters per minute for first fire and 9100 to 36400 liters per minute for second fire. Last one, if you need to calculate fire demand using Buston's formula, then fire demand Q is equals to 5663 root P. Again, fire demand is calculated in the form of discharge in liters per minute, and again the population P is kept in thousands. P is the population of the community in thousands. All these formulas are very important. It will be clearly mentioned in the question using which formula you need to calculate fire demand. So don't make a mistake. If it is asked in the examination to calculate the fire demand using Cutsling's formula, use it. Do not use any other formulas. One more thing, all these formulas will not going to give you the same value of fire demand. All these formulas will going to give you different values of fire demand. Now, how the environmental condition exists, depending on that, we will going to choose one formula for a particular city, right? All these empirical relations are derived for a particular set of condition. So if a city favors one particular set of condition for which one empirical formula is derived, we will going to choose that empirical formula, not our scope of study. For GATE examination, the only thing important is you need to know all these relations, and in the examination, whichever relation is asked, you need to just solve it, right? Chalo, quickly tell me this. If the population of the community is 1,80,000, if the population of the community is 1,80,000, what is the fire demand? What is the fire demand? First, what is the fire demand? According to National Board of Fire Underwriters method, according to National Board of Fire Underwriters method, Fire Underwriters method, according to National Board of Fire Underwriters method. Tell me quickly. Chalo, quickly, everyone should answer this. What is the fire demand as per National Board of Fire Underwriters method? So first one, as per National Board of Fire Underwriters method, if population is less than 2 lakh, if population of the community is less than 2 lakh, then fire demand Q is equal to 4637 root P into 1 minus 0.01 root P. 4637 root P into 1 minus 0.01 root P, and again the fire demand is calculated in liters per minute. Just substitute the value of P and get the value of Q. So here population is 180, so the value of P will be, population is 1,80,000, so the value of P will be 180. Substitute 180 here. So Q is equal to 4637 under root of 180 into 1 minus 0.01 under root of 180. Just do this calculation and tell me the answer quickly. Do this calculation and tell me the answer quickly. As per National Board of Fire Underwriters method, you need to calculate the fire demand. Do it. It is under root of 180 into 0.01 minus 1 minus answer into root 180 into 4637. how much it will be? So this comes out to be 53. This is 53865.28 liters per minute. This is as per National Board of Fire Underwriters method. Okay, this is as per National Board of Fire Underwriters method. Next, you calculate the fire demand using Government of India manual formula. Again, the population is 1,80,000. Population is 1,80,000. Population of the community is 1,80,000 as per Government of India manual formula. As per Government of India manual formula, fire demand Q is equal to 100 root P, and here it is calculated in kiloliters, right? So again, the value of P is 180 because population is 1,80,000. So population P, the value of P will be 180, right? So fire demand is equal to 100 root of 180. Do this 100 root of 180. So root 180 multiplied by 100. How much it is? This is 1341. This is 1341.6 kiloliters. This is the fire demand as per National Board of Fire Underwriters method. Okay, next. Calculate the fire demand using Kachling's formula. Calculate the fire demand. Population is same. Calculate the fire demand using Kachling's formula. Calculate the fire demand using Kachling's formula. Calculate the fire demand using Kachling's formula. So fire demand using Kachling's formula, Q is equals to 4637. So it is, sorry, this is not 4637. For as per Kachling's formula, this is 3182 root P. This is 3182, जोश ज़्यादा है, 3182 root P liters per minute. It is 3182 root P liters per minute. Even I used to forget the formula. Chalo, calculate the fire demand using Kachling's formula. So Q is equals to 3182 root of 180. P is 180. This will come out in liters per minute. Do it quickly. So this will come out as root 180 into 3182. How much it is? 3182. This will be 42691. This will be 42691 liters per minute. This will be 42691 liters per minute. This is your fire demand as per Kachling's formula. Next, calculate the fire demand as per Boston's formula. Calculate the fire demand as per Boston's formula. Same. Population is same, 1,80,000. Population is same. So as per Boston's formula, Q is equals to 5663 root P. Again, it will be in liters per minute. Again, I am telling you, units are very, very important. Units are very, very important. The units in which you are substituting the value and the unit in which you are getting the answer, because all these are empirical relations. Do it quickly. So as per Boston's formula, this is equal to 5663. This is equal to 5663 under root of 180. Do this quickly. Do this. This is 5663 under root of 180. So root 180 multiplied by 5663. How much it is? This is 75977. This is 75977 liters per minute. You can clearly see that as per all the empirical relations, the fire demand is different. So don't be in this idea that you will get the fire demand as one value. Different formulas, different fire demand. It will be clearly mentioned in the question which formula you need to use to calculate the fire demand. Okay, so don't apply your brain here, right? Just use the formula, calculate the answer and get the correct answer. Keep check on the unit. Okay, chalo, moving on with this. Next thing is, what are the different factors that affects the fire demand, right? My dear students, there are different factors that affects all these fire demands. How many fire demands we have calculated? Fire demands are like domestic demand, industrial demand, institutional demand, water for public use, fire demand, and then you have thefts and losses. So all these fire demands, different types of water demands are affected by different factors. The first factor that affects the fire demand is the type of sewerage system, my dear students. This is very much clear. If your sewerage system is not efficient, if it is not efficient, your domestic demand will be affected. Right? If your sewerage system is not affected, if your sewerage system is not efficient, you will use more water in your toilets, right? So it is as simple as that. If your sewerage system is not efficient, your domestic demand will be affected. Your domestic demand will be more. If your sewerage system is not efficient, your domestic demand will be more. Next, extent of industrialization. I have already told you this. More industries in the community, more will be your industrial demand. So if it, first of all, this affects the industrial demand, more the extent of industrialization, more will be your industrial demand. Next, size of the city, my dear students. One of the very, very important parameters, size of the city. If the size of the city is more, if size of the city is more, then you have more length of road networks. If size of the city is more, then you have more length of road networks, right? You have more public gardens. If size of the city is more, then you have more length of the road network, you have more public gardens, right? If size of the city is more, you have more length of the road network and you have more public gardens. It means that water required for public use will be more. So if size of the city is more, water required for public use will be affected. More the size of the city, more will be the length of road networks, more will be the public gardens, more will be the water used for cleaning the roads and for gardening purposes, hence more will be water for public use. Next one is your type of gentry. It is said that if the class of living is high, then water for domestic use increases, right? So if class of gentry is more, first of all, it affects the domestic demand. High class people usually consume more amount of water. This is just a perception, right? So it is taken as a factor that if class of living or the standard of living is high, then water for domestic demand will be more. Next, you have the climatic condition. We have usually seen this. If the climatic conditions are hot, again water required for domestic use will be more. You take like 2 or 3 times bath during summers and you can relate directly with that. If the climatic conditions are hot, water required for domestic use will be more. Hence, climatic conditions directly affect the domestic demand. Next is the cost of water and quality of water. Now, my dear students, these two things you need to understand. There is one thing known as demand and the another thing which is known as consumption. There are two things. First one is demand and second one is consumption. Second one is consumption. I'll start like this. If cost of water is more, right? If cost of water is more, then the consumption of water will be less, but demand will be same. Again, I'll explain you this. For example, you want to have 2 glasses of water, that will going to take away all your thirst. Okay. Now what happens is, due to high cost, you only consumed 1 glass of water. Now this is how you can relate with the consumption and demand. Demand was of 2 glasses. But due to high cost, you have only consumed 1 glass of water. So this 1 glass is your consumption, but actual requirement is your demand, right? So cost of water and quality of water, they indirectly affects the water demand. They affect the consumption of water. They affect the consumption of water. They do not affect the demand of water. So please keep a check. A good multiple select question can be framed from these statements. Okay, so cost of water and quality of water affects the consumption of water, not the water demand. Last one is the pressure in the water distribution system. If pressure in the water distribution system will be more, then obviously the losses will be more, hence your total demand will be affected. So if I want to just summarize this entire thing, first of all, type of sewerage system affects the water demand. Second, extent of industrialization affects the industrial demand. Third, size of the city, it affects the water for public use. Fourth, you have the type of gentry. Type of gentry affects your domestic demand. Next is your climatic condition. Climatic condition again affects your domestic demand. Then you have cost of water and quality of water, that affects the consumption of water, not the water demand. That's why we say this, the cost of water and the quality of water indirectly affects the water demand. Last one is pressure in the distribution system. So pressure in the distribution system affects the thefts and losses, right? So these are the different factors that affects your water demand. Now next is, if I talk about this water use, right? If I talk about this water use, just one second. If I talk about this water use, then we should be aware about the fluctuation in the water demand, right? The maximum amount of water in the entire year used in 1 hour is known as maximum hourly demand. Second one is, the maximum amount of water used in 1 day is termed as maximum daily demand. Okay, now we take the average value, so that is known as average hourly demand and the average daily demand, right? The duration can be anything. So for every particular duration, we have the average demand and we have the maximum demand. From the average demand, how much the maximum demand is varying, that is known as the fluctuation in the water demand. Again, I am telling you this, duration can be anything. Duration can be starting from 1 hour to 1 day, to 1 week, to 1 month, to 3 months, to 6 months, any duration up to 1 year, from 1 day to 1 year or 1 hour to 1 year, duration can be anything. But for a particular duration, you calculate two demand, average demand and the maximum demand. The amount by which the maximum demand varies from the average demand is termed as the fluctuation in the water demand. Now the percentage ratio of maximum demand to average demand is calculated using the Goodrich's equation. The percentage ratio of maximum demand to average demand is equal to 180 into T raised to the power minus 0.1, and here T is the time and there is one condition, T should be always greater than or equal to 1 day. The minimum time that you can substitute in this equation is 1 day. Right, so from one thing is clear from this equation, that you cannot calculate the ratio of maximum demand to average demand for hourly duration. You can calculate this ratio for 1 day or more, not less than 1 day, right? As per this formula, we have calculated the fluctuation in water demand. If your duration is your hourly demand, the fluctuation is 2.7. If your duration is daily, right, for 1 day, the fluctuation in water demand is 1.8. For weekly demand, the fluctuation is 1.48, for monthly demand it is 1.28, and for yearly demand is 1, right? Now, how to understand these fluctuations? For example, if I take this example of daily demand, the fluctuation in daily demand is 1.8. What do you mean by this? The fluctuation in daily demand, I write like this, fluctuation in daily demand, is how much? 1.48. The fluctuation in daily demand is how much? 1.28, sorry. The fluctuation in daily demand is 1.8, right? Now, what do we mean by this, right? How do we interpret this? This is the ratio of maximum demand to average demand. Maximum daily demand to the average daily demand. This is the ratio of maximum daily demand to average daily demand. This is 1.8. This is how we read the fluctuations, right? Similarly, if the fluctuation in weekly demand is given as 1.48, if the fluctuation in weekly demand is given as 1.48, what does it mean? It means that maximum weekly demand to average weekly demand, this is equal to 1.48. 1.48 is equal to 1.48. Please keep a check on all these important things. This is how we read the fluctuation. Okay, you can expect a very simple 1-mark question, and that question can be, okay, we will also going to frame some question instantaneously. Whichever question going to hit me, I am going to frame it instantaneously. You should be able to solve it and answer me quickly. Tell me, find the percentage ratio of find the percentage ratio of maximum demand to find the percentage ratio of maximum demand to average demand for the duration of 3 months. 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 Right? Please do it. Calculate the percentage ratio of maximum demand to average demand for the duration of 3 months. Do it quickly. Comment to answer quickly. Use the Goodrich equation. Don't forget to use the Goodrich equation. Just do it. Calculate the percentage ratio of maximum demand to average demand for the duration of 6 months. For doing it, for solving this type of question, again, you will going to use the Goodrich equation. The percentage ratio of maximum demand, to average demand, the percentage ratio of maximum demand, this is the percentage ratio, don't forget the percent, is equal to 180 into t raised to the power minus 0.1. This is the percent, right? You will not get the answer in the ratio. You will get the percentage for this formula. So, okay, for the duration of 3 months, you need to calculate. How many days in 3 months? What is the value of t for 3 months? So, value of t in 3 months is equals to 3 into 30. 1 month 30, so for 3 months it will be 90 days. So, the value of t is 90. Substitute in this equation. So, the percentage ratio for maximum demand to average demand for the duration of 3 months is equal to 180 into 90 raised to the power minus 0.1. This is the value. The percentage ratio of maximum demand to average demand is 180 into 90 raised to the power minus 0.1. Do this quickly. Tell me the answer. Please comment your answer. It is 180 into 90 raised to the power 0.1. So 90 raised to the power 0.1. Do it. 90 raised to the power minus 0.1 multiplied by 180. Multiplied by 180. So how much this is? This is 114.77. This is 114.77. This is the percentage. Don't make silly mistakes, right? This is the percentage you have calculated. If you have to only calculate the ratio will be 1.147. This is the percentage ratio. Percentage ratio is 114.77. This is your percentage ratio. Just quickly try one more. Get me the percentage ratio of maximum demand to average demand. Find the percentage ratio of maximum demand. Find the percentage ratio of maximum demand to average demand. Find the percentage ratio of maximum demand to the average demand for the duration of how much? For the duration of 8 months. Let's say 8 months. Okay. For the duration of 8 months. Quickly do it and tell me the answer. What is the percentage ratio of maximum demand to average demand for the duration of 8 months? Again, for calculating this, you need to use the Goodrich equation, which is equal to P is equals to maximum demand to average demand. Maximum demand to average demand. The percentage ratio of maximum demand to average demand. The percentage ratio of maximum demand to average demand is 180 into t raised to power minus 0.1, right? This is the percentage ratio of maximum demand to average demand. Again, for the duration of 8 months, what is the value of t? Okay, so 8 months is 8 into 30, so this comes out as 240 number of days. Take the value of t as 240, substitute here and get the percentage ratio. So percentage ratio is 180 into 240 raised to the power minus 0.1. Calculate this and tell me the answer, the percentage ratio for the maximum demand to average demand. Do this. How much it is? This is 240. This is 240 raised to the power minus 0.1 into 180. How much it is? This is 1.04, this is 104, this is 104.05. This is the percentage ratio. Again, I am telling you, this is the percentage ratio, percentage. If I only ask you the ratio, this will be 1.04, but percentage ratio is 104.05%. Okay, here I would like to add one more point, and that point is, you can see here, as the duration is increasing, as your duration is increasing, the value of fluctuation is tapering down. So you will get the highest fluctuation for hourly demand and you will get the least fluctuation in your yearly demand. This is related using the concept of statistics. If you increase the sample size, your fluctuation also decreases. So as you are increasing the number of days, the fluctuation in the water demand is also decreasing. Highest fluctuation is corresponding to the hourly demand and the least fluctuation is corresponding to your yearly demand. Okay, this is one of the very important factor, very important parameter. Let's move ahead. Okay, so this is all about your water demand, right? These are all the important formulas for water demand from where the questions can be framed. The very important part is factors affecting the water demand, where you can expect a multiple select question. Second one is the concept of your fire demand. All the empirical formulas are very important. Third very important area is the fluctuation in the water demand, especially last part, that is your Goodrich equation, right? Now moving ahead, for calculating the water demand, you need to know the population of the community. For knowing the population of the community, we have different things. We have different methods. The first method of forecasting the population is termed as your arithmetic increase method. As per arithmetic increase method, the population after n decades, Pn, is equal to P naught plus Nx bar. Here the value of P naught is the last known population, X bar is the average increase in population, and N is the number of decades after which you have to forecast the population. So as per arithmetic increase method, the population after n decades, Pn is equals to P naught plus Nx bar. Very simple, Pn is equals to P naught plus Nx bar, where P naught is the last known population, N is the number of decades, and X bar is your average increase in population. Second one is your geometric increase method. Very important, geometric increase method. As per geometric increase method, population after n decades is equals to Pn plus P naught. Pn is equals to P naught into 1 plus R raised to the power n. Here the value of Pn is again population after n decades. P naught is the last known population, R is the percentage increase in population, and N is the number of decades after which you need to forecast the population. So using geometric increase method, your Pn, that is population after n decades, is equals to P naught into 1 plus R raised to the power n. Okay, this is your geometric increase method. Next, as per your incremental increase method, we are only dealing with the formulas. Formulas are very important. If you know the formulas, question can be dealt easily, especially from this segment, right? Next one is your incremental increase method. As per incremental increase method, population after n decades is equals to P naught plus Nx bar plus N into N plus 1 into Y bar. Here X bar is the average increase in population and Y bar is the incremental increase, that is increase over increase in population. So Pn is equals to P naught plus Nx bar plus N into N plus 1 into Y bar. N into N plus 1 by 2. 2 is written here. This is N into N plus 1 by 2 into Y bar, right? Here X bar is the increase in population, Y bar is the incremental increase in population, right? Now one more thing, my dear students, if I want to analyze the total population of the community, the total population of the community is affected by 4 factors. First factor is number of birth taking place in the community. Number of birth taking place in the community. The number of birth taking place in the community will going to increase the population of the community. Second one is the number of death taking place in the community. The number of death taking place in the community will going to reduce the population of the community. Third one is the migration happening in the community, whether it is inward migration or outward migration. If you talk about the city like Bangalore, you will see huge amount of inward migration. People are migrating from other cities to the city of Bangalore. So this results in the increase in population of the city of Bangalore. So if I talk about the different factors which affects the population of the community, the first factor that affects the population of the community is number of birth, second is number of death, third one is the inward migration, and fourth one is the outward migration, right? Chalo, moving on with this. You have a very beautiful question in front of you. Just try this. It was a GATE previous year question asked for 2 marks. I have just changed few data and framed it into a new question, right? Even I have changed the concept also. Similar variety of question was asked in your GATE examination. Just try this, give your answer. Try this and give your answer. Keep commenting your answer. Let me clear my throat and then we will going to discuss this. Chalo, let's see this question. This question says that every question is very easy first of all. If a question is from environment, it should be an easy question. The only thing required is you need to understand the question very properly. Environment is the only subject where there is very limited scope of question framing. So if a question comes from environment, don't miss it, because very limited areas are there from where questions can be framed from environment. First thing. Chalo, let's see this. Question says that the present population of the community is 30,000. The present population is 30,000. Very clear. The present population is 30,000. Means the value of P naught is 30,000. The value of P naught. Present population of the community is 30,000. Very much clear to us. Next, with an average water consumption of 5,000 meter cube per day. Means that this 30,000 population consumes 5,000 meter cube per day of water. This 30,000 population consumes 5,000 meter cube per day of water. Can you tell me what is the water consumed by one person? The water consumed by one person will be water consumed by one person. Water consumed by one person. This is equal to 5,000 divided by 30,000. This is the water consumed by one person, and this will come out in meter cube per day. This is the water consumed by one person in one day, and this is 5,000 by 30,000. Okay, simple. Right now what we know? We know the present population of the community, which is 30,000, and this 30,000 population is consuming 5,000 meter cube per day of water. Next, the existing water treatment plant has a design capacity of 7,500 meter cube per day. It means that the existing water treatment plant can treat a water of 7,500 meter cube per day. That is the total amount of water the water treatment plant can treat. But right now, how much water is treated by the water treatment plant? Right now, 5,000 meter cube per day of water is treated by the water treatment plant. Right now, water treatment plant is treating only 5,000 meter cube per day. What is the total capacity? 7,500 meter cube per day. Let's see what the question is saying. It is expected that the population will increase up to 45,000 during the next 20 years. It is expected that the population is to be increased up to 45,000 in the next 20 years. My dear students, if the population is increasing, right, obviously this water consumption will also increase. Right now, 30,000 population is consuming 5,000 meter cube per day of water. If population will increase, then this water demand will also increase. Okay, now the question is saying the number of years from now, please focus on this. The numbers of years from now when the plant will reach its design capacity. The number of years from now when the plant will reach its design capacity, assuming the geometric rate of population growth. Such an easy question. Asked for 2 marks. I have changed the concept also, but same question was asked in GATE examination. Such an easy question. What the question says? Right now the population is 30,000, consuming 5,000 meter cube per day of water. Next, it is expected that the population will increase to 45,000 in next 20 years, right? The total capacity of water is given to you of the water treatment plant. Now the question is asking in how many years the the treatment plant will reach its design capacity. So let's solve this. First of all, I'll just do it like this. P naught is 30,000. This is the population of the community, and this population is consuming 5000 meter cube per day of water. Okay, this is the first layer of question. The second layer of question says that in next 20 years, right, in next 20 years, that is P2, that is after 2 decades, the population will increase up to 45,000. In next 20 years, the population will increase up to 45,000. Next part is the design capacity of the water treatment plant is 7500 meter cube. Okay, 7500 meter cube per day, and this design capacity means this quantity of water will be consumed by some population Pn. This quantity of water will be consumed by some population Pn. We are asked to calculate in how many years the population will increase from P0 to Pn. It is as simple as that. We are asked to calculate in how many years the population will increase from P0 to Pn. This is the simple question. Okay. So for calculating this, in how many years the population will increase from P0 to Pn. So by geometric increase method, by geometric increase method, Pn is equal to P0 into 1 plus r raised to the power n. 1 plus r raised to the power n, right? Do I know the value of P0? Yes, I know the value of P0. Do I know the value of Pn? Very, very important question. Do I know the value of Pn? Yes, my dear students, I know the value of Pn. Because from this data, I know what is the per capita water demand. Using this data, I know what is the per capita water demand. We have calculated this is the water consumed by one person in one day. So, how many people will consume this much amount of water can be calculated. So, the value of Pn is equal to 7500 divided by per capita water consumption. Divided by per capita water consumption. Divided by per capita water consumption, right? So this is 7500, clearly 7500 divided by 5000 divided by 30,000. Divided by 30,000, right? So this 30,000 will come into the numerator. This is 3 times, this is 2 times. This is 3 times, this is 2 times, right? Now this 30,000 will come in the numerator. So Pn will be how much? This is 3 by 2 of 30,000. This is 3 by 2 of 30,000. So this is 1 times, this is 15,000 times. This is 15,000 times. Okay, so luckily you have the value of 4500. You have the value of 4500, right? Luckily you get the value of 4500. You get the value of 4500, and we know that in next 20 years the population will increase to 4500. Okay, the next step of the question would have been, if this would have been some other value instead of 4500, then we have calculated the value of R using this data, and then finally we have reported the answer. Okay, then we have calculated the value of N. Using this data, we have calculated the value of R, and then we have calculated the value of N by substituting the value of Pn, P0 and R. Right now I already know that Pn is 4500. Okay, so 45,000. This 45,000 population will going to consume 7500 meter cube per day of water. Okay, and this 45,000 population will be reached after 20 years. So number of years in which the plant will reach its design capacity is 20 years. This is my final answer. Number of years in which the plant will reach its design capacity is 20 years, right? So this is my final answer. Chalo, moving on with this next question. Next thing, okay. Okay. So first, water demand. Second is population forecasting. So we need population of the community to calculate the water demand. For calculating population of the community, we had different methods. For population forecasting, after forecasting the population, we calculate the water demand of the community. Okay. Now, once we know the total quantity of water required in the community, the next thing we need to find out from where we should extract this water. Whether we should extract this water from any river, any well we should dig, any infiltration gallery. The second thing of discussion will be the different sources of water from where we will going to extract this water. Okay. So, once we know the total quantity of water required in the community, the next thing is identifying the different sources of water. So, next topic is sources of water. My dear students, if I talk about sources of water, I should write like this. If I talk about sources of water, if I talk about sources of water, right? If I talk about sources of water, there are two types of sources. First one is your surface source. First one is your surface source, which includes rivers, oceans, seas, lakes, etc. First one is your surface source. First one is your surface source, which includes rivers, lakes, ponds, seas, oceans, etc. Sea, oceans, right? Earlier, sea and ocean were not the source of water, but luckily from last 4-5 years, sea and ocean are the potential source of raw water. So, if a question is asked in an interview, is sea and ocean are the source of raw water? Confidently say it, yes. Yes, it's a source of raw water. Okay. Now, we have the technology to extract water from sea and ocean and treat it for supplying it to the community. Okay. And right now we are also doing in the state of Gujarat. We have imported some technology from Israel which is capable of treating this water, especially sea water or ocean water, and using it for domestic purposes, also for industrial purposes. So, first type of source is your surface source. Surface source include rivers, seas, oceans, lakes and ponds. The second one is your subsurface source. 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 Now, subsurface source include aquifers. The subsurface source includes aquifers, right? What are aquifers? Aquifers are something. These are geological formations which contains saturated soil mass, in which or from which we can very easily extract the underground water. So, the subsurface source can be your aquifers. Springs can also be a source. Aquifers, springs, these two are your subsurface source of raw water, right? Okay, so for extracting the water, how many sources we have? We have two types of water source. First one is your surface source, second one is your subsurface source. Surface source includes rivers, lakes, ponds, seas and oceans. Subsurface source include aquifers and springs, right? Next is your groundwater development. If you move below the ground level, okay, I'll just quickly explain you this. Next one is your groundwater development. Groundwater development means in which state we get the water if we start moving below the ground. Groundwater development. Second one is your groundwater development, right? Now observe this very carefully. This is my ground level. This is my ground level, right? I am moving below the ground level. This is my ground level and I am moving below the ground level. The area below the ground level can be broadly classified into two layers. The area below the ground level can be broadly classified into two layers. Okay, carefully listen to me. The area below the ground level can be broadly classified into two layers. Okay, this is, okay, one second. The area below the ground can be broadly classified into two layers. First layer or the bottommost layer is known as zone of rock flowage. This is known as zone of rock flowage. Zone of rock flowage. This is known as zone of rock flowage. Now, what is the characteristic thing about this zone of rock flowage? My dear students, we cannot extract water from this. Okay, here the water will be present inside the crystal structure of the soil. So, we cannot extract water directly. We have to break the crystal structure, which requires huge amount of energy and which makes this zone not feasible to extract the underground water. So, two things. First one is we cannot extract water from this zone. Reason? Water is present inside the crystal structure. In order to extract water from this zone, we need to break the crystal structure and then extract the water, which is not a feasible source, right? Above this zone of rock flowage, we have the zone of rock fracture. We have this zone of rock fracture. This is zone of rock fracture. This is zone of rock fracture, right? In this zone of rock fracture, water will be present in the voids. Okay. Here the water was present inside the crystal structure, but in the zone of rock fracture, the water will be present in the voids. Now this zone is also classified into different layers. This zone of rock fracture is also classified into different layers. The first layer is known as zone of saturation or groundwater table zone. This is zone of saturation. This is known as zone of saturation. Zone of saturation. This is known as zone of saturation or groundwater table zone or groundwater table zone. Groundwater table zone, right? The groundwater table will be present in this zone. The soil in this zone will be completely saturated. So the degree of saturation for this zone is equal to 1. This is one of the most potential area from where we extract the underground water. Or I should say like this is the only area from where we extract the underground water. This is the zone where underground water can be very feasibly extracted from this zone, right? This is the only zone from where the underground water can be extracted. Above this zone, we have the capillary water zone. Above this zone, we have this capillary water zone. This is my capillary water zone. This is my capillary water zone. This is my capillary water zone. Now, capillary water zone is also 100% saturated. This capillary water zone is also 100% saturated due to capillary action. This capillary water zone is also 100% saturated due to capillary action. The degree of saturation for capillary water zone is also 1. But due to capillary tension, extracting water from this zone is again not feasible. Due to added capillary tension, we have to first overcome this capillary tension in order to extract water from this zone. That's why this zone is not a feasible area to extract the underground water. If anybody asks you what is the degree of saturation for capillary water zone, it is completely saturated. Degree of saturation is 1. But this zone is not the feasible zone for underground water extraction. We cannot feasibly extract underground water from this zone. But all the voids will be filled by the water due to capillary action. Above this zone, we have intermediate water zone. Above this zone, we have intermediate water zone. This is my intermediate water zone. This is intermediate. This is intermediate water zone. This is intermediate water zone. For intermediate water zone, degree of saturation is less than 1. For intermediate water zone, degree of saturation is less than 1. Again, not the feasible source of underground water. Okay, next one is above this, we have the root zone. We have the root zone. Now, for root zone, again degree of saturation can be less than or equal to 1. Root zone is the zone where the roots of the plantation or the vegetation that you did over the ground exist, right? This root zone can have degree of saturation less than 1 or equal to 1. When you flood the field, the degree of saturation becomes 1. And during the dry seasons, right, the degree of saturation is less than 1. Again, these two zones are not the feasible area for the extraction of underground water. So if I have to just summarize this entire thing, there is only one layer which is known as zone of saturation or groundwater table zone, from where we can extract the underground water feasibly. Okay, so these are the different layers as we move below the ground level, and this is known as groundwater development. Okay, we cannot extract water from zone of rock flowage because water will be present in the crystal structure. Second, we cannot extract water from capillary water zone because the water in this zone has added capillary tension. So in order to overcome capillary tension, we need to supply extra energy that makes it not feasible to extract water from this zone. Then you have intermediate water zone. This zone is having less than, degree of saturation is less than 1, and then you have the root zone. Okay, chalo, moving on with this. Next is, if you have this zone, okay, zone of saturation. Now we need to analyze how easy it is to extract water from this zone of saturation. So for analyzing how easy or how feasible it is to extract water from zone of saturation, we require two parameters. The first parameter is termed as porosity. My dear students, porosity tells me about the quantity of water which is stored in the zone. Porosity, okay, don't go into the definition. Definition of porosity is volume of voids divided by the total volume. Volume of voids tells us about how much volume or how much space is available for the water storage. More the volume available, more will be the water storage, or I can say this, more the porosity of the soil medium, more will be the water storing capacity of the soil medium. Okay, so porosity tells me about the water storing capacity of the soil. More the porosity of the soil, more will be the water storing capacity of the soil. Okay, so first parameter is porosity. Porosity is volume of voids divided by total volume of soil medium. Next one is your permeability. My dear students, permeability is, first of all, what is permeability? Permeability is the ease with which water can flow through the interconnecting voids. If water is flowing easily through the interconnecting voids, then the permeability of the medium will be more. If water is facing so much of hindrance in flowing through the interconnecting voids, then the permeability of the soil medium will be less. Here I would like to make you realize one point. If this is my soil medium, and water is flowing through like this through the interconnecting voids, okay, if water is flowing through this, flowing like this through the interconnecting voids, now please keep a check on this, right? This surface of the soil medium, which is in contact with the flowing water, this surface of the soil medium which is in contact with the flowing water will going to apply the frictional force over this water, and this frictional force will cause the hindrance in the flowing of this water. So more the area in contact with the water, more will be the frictional force applied by the surface of the soil medium over the water. So I can say that for finer soil medium, okay, if the size of the soil medium is less, for fine soil, the permeability will be less. For fine soil, the permeability will be less. Reason is the specific surface area for fine soil will be less. Specific surface area for fine soil will be more. So permeability for fine soil will be less. Second, for fine soils, the porosity will be very high. Okay, so fine soils can store huge amount of water, but on the same time, extracting water from the fine soils will have huge amount of added friction, which makes the extraction of groundwater from the fine soils very difficult. So one thing I would like to conclude here, fine soil has high porosity. For fine soils, porosity is very high, but permeability K is very less. Similarly, for coarse soil, the porosity will be less. But permeability will be high. Why permeability is high? Because specific surface area for coarse soil is less. If specific surface area is less, this surface area will apply less friction through the flowing water. Okay. So two factors which governs the extraction of groundwater is porosity and permeability. Just give me 1 second. Two factors which governs the extraction of groundwater is porosity and permeability, right? Next one is your average velocity of flow, V is equal to K into I. The average velocity of flow is V is equals to K into I. But this is not the velocity of flow. This is not the actual velocity of flow. The actual velocity of flow is your seepage velocity, which is equal to average velocity of flow divided by porosity into degree of saturation. So average velocity of flow is K into I. Then your seepage velocity or the actual velocity of flow through which the water will flow inside the soil medium. This is your seepage velocity, and this is derived using Darcy's law. This is derived using Darcy's law. Right? So if I have to ask you by which velocity the water will flow inside the soil medium, so the answer is your seepage velocity. Right? As simple as that. And what is seepage velocity? Seepage velocity Vs is equal to average velocity divided by porosity into degree of saturation. Chalo. So this is the thing. Let's move to a question. Here is a question, just try this. You have a very beautiful question. Again, a GATE previous year question. Just try this. Again, a GATE previous year question. Try this. Again, a GATE previous year question. What the question says? Question says that two wells are situated at a distance of 2 kilometer. Two simple wells are situated at a distance of 2 kilometer. Two wells are of 2 kilometers. Just try this question. The battery is losing. This question, try this question. The question says that two wells are situated at a distance of 2 kilometers from each other in the soil medium, indicating the head difference of 2.5 meter in the direction of flow. If the porosity and permeability of the soil medium are 25% and 50 meter per day respectively, then compute the time taken by the inner tracer to pass from one well to the another in the direction of flow. Two simple wells are given to you and head difference is given to you. Okay, check this. Two wells are given to you like this. Let me draw it quickly. So two wells are given to you like this. This is my ground level, and in this ground I have two wells. This is my well number 1 and this is my well number 2. Okay, the water is flowing from one well to the another. The water is flowing like this from one well to the another. Okay, now the difference in head between the two wells is given as how much? The difference in head between the two wells. Okay, so this is the water level in first well and this is your water level in the second well. This is your water level in the first well. This is your water level in the first well and this is your water level in the second well, right? This head difference is given to you. This head difference is given to you as 2.5 meter and the distance between the well is 2 kilometer. So this head difference is 2.5 meter and the difference and the distance between the well, this is given as 2 kilometers. So I write down is 2000 meters. Okay, this is the distance between the well. Okay, now the question is asking, if you drop an inner tracer in well number 1, in how much time it will reach to well number 2? In how much time this inner tracer will reach to well number 2? If you drop an inner tracer like this, what is an inner tracer? You can imagine it like an ink. If you drop a drop of ink here in well 1, in how much time it will flow to well number 2? That is asked, right? This is my well number 1, this is my well number 2. So first of all, my dear students, this inner tracer will travel through the seepage velocity. So inner tracer will travel by seepage velocity. Inner tracer will travel by seepage velocity. So first of all, I should know the seepage velocity. What is the seepage velocity? Seepage velocity Vs is equal to average velocity of flow into porosity into degree of saturation, right? So first of all, I need to calculate this average velocity of flow. So average velocity of flow is equal to K into I. Now observe this. Average velocity of flow V is equal to K into I. K I already know. K is the permeability. It is given to us. But I need to calculate. Okay. I need to calculate. I is hydraulic gradient I is equal to head loss divided by the length of flow. Is equal to the head loss divided by the length of flow, right? You can clearly see between well 1 and well 2, this is the amount of head which is lost and this is equal to 2.5 meter. So head loss is 2.5 meter, length of flow, the distance between the two wells which is 2000 meter. So length of flow is 2000 meter, right? So this is your hydraulic gradient. K you already know, you can calculate the average velocity. So average velocity V is equal to K into I. K is given as, I think, 50 meter per day. This is 50 meter per day. This is 50 meter per day multiplied by I. I is 2.5 divided by 2000. So this is your average velocity of flow in meter per day. Units are very important, and the units in which you need to report the answer, that is also very important. Don't solve the question and mark the incorrect option just because of the unit. That is one of the least thing you can do in your examination. Okay. Now this is your average velocity. Using this average velocity, calculate the seepage velocity. So seepage velocity is equals to average velocity into porosity into degree of saturation. You can see here the soil is flowing, this water is flowing from well 1 to well 2, and this is the level surface of the water, right? So the soil is completely saturated. So degree of saturation is 1. Porosity is given to you as 25%. Porosity is 25%. Okay, porosity is 25%. So this is 50 into 2.5 divided by 2000. This is your seepage velocity, this is your average velocity, this is meter per day, divided by porosity 25%, so 0.25 into degree of saturation is 1. So this will going to give you the seepage velocity. Just do the calculation, tell me the answer. Tell me the answer for seepage velocity. Okay, even if you don't calculate this, we got the seepage velocity. Now we can calculate the time. Time taken by inert tracer is, time taken by inert tracer is, time taken by inert tracer is, time taken by inert tracer is distance between the two wells. So distance between the two wells is 2000. Distance between the two wells divided by the seepage velocity. This is your seepage velocity. 50 into 2.5 divided by 2000 into 0.25. You will solve this and you will get the answer in days. Okay, don't make the mistake. This is your meter, this is meter per day. So you will get the answer in number of days. Do this, do the calculation. So this is 2000 square into 0.25 divided by 50 divided by 2.5. So this comes out as 8000 days. You need to report the answer in number of years, right? So right now your answer is 8000 days divided by 365. So this will come out as 21.92 years. This will come out as 21.92 years. In this much time, your inert tracer will reach from one well to the another. Okay, one more thing, my dear students, whenever you are calculating any answer, believe in your answer, right? Some of the students, after calculating this answer, they feel less confident. Okay, so you have to analyze it first, right? This permeability, porosity, okay, so water seeps inside the soil and the velocity is not even visible to us sometimes. The velocity is very less. So your answer can be like this. So don't worry about it, right? Chalo. Moving on with this, next is, okay. Now, if the water is flowing under the action of gravity, like this, if the water is flowing under the action of gravity, if the water is flowing under the action of gravity, let me just draw it quickly. So if the water is flowing under the action of gravity like this is my ground level, this is my ground level, this is my ground level, and this is the impermeable layer. This is my ground level, this is my impermeable layer, and in between the ground level and impermeable layer, I have the groundwater table. So this is my groundwater table. This is my groundwater table like this. Right. Now the water is flowing under the action of gravity like this. The water is flowing under the action of gravity. And this water is flowing through the interconnecting voids of the soil. Right. Water is flowing under the action of gravity and the water is flowing through the interconnecting voids of the soil medium. So my dear students, two things you should take care, right? First of all, not the 100% water will flow out, right? Not the 100% water will flow out of the soil medium. Some quantity of water will be retained in the soil medium. So if you observe the soil medium very carefully, if I draw the soil medium like this, if this is my soil medium, right? Let me just draw this soil medium quickly. This is my soil medium. These are the different soil particles. Okay, I am just exaggerating the picture. I am just drawing the small soil particles into larger soil particles to make you realize how the things are happening. So all these are my soil particles. These are my soil particles, right? These are my soil particles, and in between these soil particles, I have the voids. In between these soil particles, I have this void. This is the void between the soil particle. Now, observe this. If this is the water which is filled inside the void, and this water is flowing out like this through the interconnecting voids, then all the water will not come out or not flow out from the soil medium. Some amount of water will be absorbed over the surface of this soil medium. Some amount of water will be absorbed over the surface of this soil medium like this. Okay, so this point is very much clear. When the water is flowing under the action of gravity through the soil medium, then 100% of the water does not flows out. Some amount of water is retained in the soil medium and it gets absorbed over the surface of the soil medium. So this is known as your adsorbed water. This is known as your adsorbed water. This is known as your adsorbed water. This is known as your absorbed water, and this adsorbed water is retained by the soil medium. Now, in order to analyze how much quantity of water is flowing out from the soil medium and how much quantity of water is retained in the soil medium, we had defined two parameters. First is known as your specific yield, which tells me about the volume of water drained under the action of gravity divided by the total volume of the soil medium. So specific yield gamma S is equals to volume of water drained divided by the total volume of the soil medium. Second one is your specific retention, which tells me about the volume of water retained against the action of gravity divided by the total volume of medium drained. Okay, so gamma S and gamma R tells me about how much water flows out under the action of gravity and how much water is retained against the action of gravity. So gamma S plus gamma R is equal to eta into S, where eta or N is the porosity of the soil medium, one of the very important parameter, one of the very important formula. A specific yield or specific retention gamma S plus gamma R is equal to N into S, where N is the porosity of the soil medium and S is the degree of saturation. Very important parameter. Let's see a question on this. Let's see a question on this. Try this question. One of the very important question with respect to GATE examination. Try this. Whenever in the question it says that calculate the change in groundwater storage. Change in groundwater storage means what is the volume of water drained? What is the volume of water drained? What is the volume of water drained? Change in groundwater storage means how much amount of water has flown out of the soil medium. So change in groundwater storage is volume of water drained. Do it quickly, do it quickly. One of the very important question. Question says that the water table of an aquifer drops by 200 centimeter over an area of 75 hectares. Means the water table was here and it dropped by 200 centimeter over the area of 75 hectares. And why this water table is dropping? This water table is dropping because the water is flowing out under the action of gravity, and that leads to the change in groundwater storage because there is some volume of water which is draining out of the medium. So if you want to solve this question can be solved like this. If this is my ground level, right, this is my ground level like this. Just to explain you, I am drawing like this, right, so that you have better clarity. Initially, this was my groundwater table. Right? Initially, this was my groundwater table. Now this groundwater table dropped by some amount. This was my groundwater table initially, then it dropped by some amount. This is the amount by which the groundwater table dropped. Okay. Now what is that amount? This is 200 centimeter. This is 200 centimeter. Okay, and the area is 75 hectares. Area is 75 hectares that we are analyzing. Over 75 hectares, the water table dropped by 200 centimeter. Okay. Now what you need to calculate? You need to calculate the change in groundwater storage, and you are given with the specific retention, and you are also given with the porosity of the soil medium. You are given with the specific retention and the porosity of the soil medium. Porosity is 25% and specific retention is 5%. So porosity is 25% and specific retention is 5%. Specific retention is 5%. First of all, if I need to calculate the change in groundwater storage, I need to know the specific yield. So for calculating the specific yield, I'll use the relation gamma S plus gamma R is equal to eta into S, right? Now, since you can see that this groundwater table is dropped by 200 centimeters, so when this water table was dropping, this entire soil would have been saturated. So degree of saturation was 1. The degree of saturation is 1, right? Substitute the value, calculate the value of gamma S. So gamma S plus 0.05, gamma S plus 0.05, it is 5%. This is equal to porosity, which is 0.25. Using this, you can calculate the value of specific yield. Specific yield is equal to 0.2. This is your specific yield. Once you know the specific yield, you have to now just apply the formula. Specific yield is equal to volume of water drained. Specific yield is equal to volume of water drained. Specific yield is equal to volume of water drained VD divided by the total volume of soil medium 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 V. Now what is the volume of water drained? That we need to calculate. What is the volume of soil medium? Volume of soil medium is 75 hectares multiplied by 200 centimeter. That is the volume of medium drained. So gamma S is equal to 0.02. This is 0.2, not 0.02. This is 0.2. 0.2 is equal to VD divided by total volume of soil medium. So total volume of soil medium is 75 hectares. So 75 into 10 raised to power 4. This will be meter square. Now you need to convert this centimeter into meter. So for converting this 200 centimeter you have. So this is equal to 2 meter, right? This is equal to 2 meter. Just solve this. Just solve this. Get the value of VD. You take this and multiply here and get the value of VD. You will get the answer in meter cube. You will get the answer in meter cube. We have already converted the 75 hectares into meters and this centimeter into meters. So 0.2 into 2 into 75 into 10 raised to power 4. So this will be 3 lakh meter cube. VD will come out as 3 lakh. VD will come out as 3 lakh meter cube. So volume of medium drained is equal to 3 lakh meter cube. Please note this down. Volume of medium drained is 3 lakh meter cube. Please note this down. The volume of medium drained will be 3 lakh meter cube. Just give me 1 second. Your volume of water drain, right? So this is your sources of water. We have other formulas of infiltration gallery. You have other formulas of wells. All those are the part of well hydraulics that you can study in irrigation and hydrology, especially in your irrigation part, right? Chalo, moving on to the very next chapter. Once you have extracted water from the source, you cannot directly consume this water, right? You need to check whether this water is good or bad. For checking the quality of this water, you require water quality parameters. So quality of water is analyzed using water quality parameters. These water quality parameters are categorized into three categories. First one is the physical water quality parameter. All those water quality parameters which can be felt or sensed by any of our senses are termed as physical water quality parameter. Physical water quality parameter include suspended solids. Suspended solids can be seen. Second, turbidity. Turbidity can be seen. Third one is your color. Color again can be seen. Next is your taste and odor. Taste and odor can be felt or smelt. Last one is your temperature. Again it can be felt. So all those water quality parameters which can be felt or sensed by any of our senses are termed as physical water quality parameters. List is suspended solids, turbidity, color, taste and odor, and last one is your temperature. Second, chemical water quality parameters. These are those water quality parameters which affects the chemical quality of water. First one is your dissolved solids. Please keep a check. Please keep a check on this. Dissolved solid is your chemical water quality parameter, and suspended solid is your physical water quality parameter. Okay, do not confuse yourself. Dissolved solid affects the chemical quality of water and suspended solids affects the physical quality of water. Second one is the alkalinity. Third one is the pH. Next is your hardness. Then you have nitrogen, chloride, fluoride content. And then you have the dissolved gases and the metals. So these are all your chemical water quality parameters. Third one is the quantity of disease causing microorganisms present in the water sample, and that is analyzed using biological water quality parameter. So biological water quality parameter totally deals with counting the colonies of pathogens. What are pathogens? Pathogens are disease causing microorganisms. So these pathogens are disease causing microorganisms. Chalo, moving on with this. First thing is suspended solids are calculated using the graviometric technique. Any technique where we measure the weight of the parameter, that is known as your graviometric technique. We have the complete test for it. I hope you remember this test. The value for which, as per National Environment Protection Act, all the values are very important because directly a statement can be framed. All the permissible limits are very important. As per National Environment Protection Act, the value or the permissible value of suspended solids in drinking water should be less than or equal to 30 milligram per liter, right? Second one is your turbidity. Turbidity is either measured by color matching technique. It is either measured by color matching technique. First thing, it is either measured by color matching technique. Since now whatever equipments we are using, that equipment uses the color matching technique for measuring the turbidity. But earlier, the turbidity was measured by measuring the length of path traveled by the light. Okay, what I am saying, first technique is your color matching technique. Earlier, the turbidity was measured by measuring the length of path, traveled by the light. Length of path traveled by the light. Length of path traveled by the light. Length of path traveled by the light. This is again a technique to measure the turbidity, right? Turbidity is either measured by color matching technique or it can be measured by measuring the length of path traveled by the light, right? How we measure the turbidity? Okay. The color matching technique uses Fuller's earth and formazine to form the color, okay. The amount of turbidity caused by mixing 1 milligram of Fuller's earth in 1 liter of distilled water is termed as 1 STU of turbidity or 1 silica unit of turbidity. Similarly, mixing 1 milligram of formazine in 1 liter of distilled water, the amount of turbidity caused by this substance is termed as 1 NTU of turbidity, right? Again, for turbidity, the permissible limit is 1 NTU and cause for rejection value is 5 NTU. Next, color is measured by color matching technique and the instrument used is known as tintometer. For making the color, we use the platinum in the form of chloroplatinate ion. The permissible limit of color is 5 TCU. Next, for taste and odor, we go with the dilution technique, and here the permissible limit is 1 TON. What does 1 TON means? 1 TON means that whatever water you are taking, that water should be free from taste and odor. That is what we mean by 1 dilution, okay. And the equipment used for measuring taste and odor is termed as osmoscope. Last one is your temperature. Temperature is measured by thermometer, and the permissible limit of temperature is 10 to 25 degrees Celsius. All the parameters are important, all the techniques are important, all the chemicals which are used to make the color, they are also important, okay. So if I have to just summarize this, suspended solids are measured by gravimetric technique. Permissible limit of suspended solid as per NEPA is 30 milligram per liter. Second, turbidity is either measured by measuring the length of path traveled by the light, or by measuring the color, or by color matching technique, okay. Color is developed either by using the Fuller's earth or formazine. Next, the permissible limit of turbidity is 1 NTU. Third one is your color. Color is again measured by color matching technique, and here the color is developed using platinum in the form of chloroplatinate ion. The equipment or the instrument used to measure color is known as tintometer. The permissible limit of color is 5 TCU. Next is taste and odor. Taste and odor is measured using the technique of dilution, and the equipment used is known as osmoscope, and the permissible limit for taste and odor is 1 TON. And last one is your temperature, which is measured by thermometer, and the permissible limit is 10 to 25 degrees Celsius. Chalo, moving on with this, take this question. Take this question, it is based on the test that we do to measure the suspended solids. Take this question, it's a very good question. Take this question. If you get a question from the measurement technique of suspended solids, you will get a question like this. Just do it. Do this question. This time I will give you a timer. Try this for 2 minutes. Try this question for 2 minutes, I will give you a timer. Try this question for 2 minutes, I will give you a timer this time. Chalo, try this. It's a very, very good question. Try this. If you can do this question, you can very definitely calculate all the parameters, and second, you exactly know the test, how to calculate the suspended solids. Let's see this question. The question is saying that, the question says that following observations are being made on a raw water sample for the determination of solids in it. A crucible was dried to a constant mass of 58.68 grams, right? So this is the empty weight of the crucible. I'll name this as W1. This is your empty weight of the crucible. Second, 50 ml of well mixed sample was taken in the crucible. So volume of the sample is 50 ml. I'll write like this. I'll write all the things. So empty weight of the crucible W1 is, this is how much? 58.68 grams. This is 58.68 grams. Second, volume of the sample is 50 ml. Okay, next. The crucible with the sample was dried to a constant mass of 61.89 gram. Now this is the weight of the crucible plus total solids. This is the weight of crucible plus total solids. So weight of crucible plus total solids is given to us. Weight of crucible plus total solids. Weight of crucible plus total solids. This is given to us as 61.89 grams. 61.89 grams, right? Next. In the oven at 104 degrees Celsius, the crucible with the dried sample was placed in the muffle furnace at 600 degrees Celsius and after cooling with residue as 60.02 gram. Compute the organic fraction of the total solids present in the raw water sample. Now observe this. How you have to imagine this question. First of all, you had this crucible like this. You had this crucible. Okay, this is your crucible. And you have taken the empty weight of the crucible. So empty weight of the crucible is 58.68 grams. This is the empty weight of the crucible, right? The crucible is now empty. Next, what you did is, you have poured the water sample into this crucible. You have poured water sample into this crucible, right? You have filled the water sample into this crucible like this. How much water sample you have filled? You have filled 50 ml of the water sample into this crucible. Now this water sample contains total solids as well. You have kept this crucible inside the oven, right? So next step what you did is, you kept this crucible inside the oven. This is your crucible. Now what you did is, you kept this crucible inside the oven. This is your oven. And this crucible contains water sample, right? Now inside the oven at 104 degrees Celsius, all the water will going to evaporate and now you will be left with the total solids, okay? So when you take out this crucible, from the oven like this, this crucible will contain only total solids. These are the total solids that crucible will contain. This is your total solids, right? This is the total solids which is contained by the crucible. Now weight of total solids with the crucible, this is given to us as 61.89 grams. This is given to us as 61.89 grams. Observe this story very carefully. It's a very, very interesting story. Directly they have given you the complete test. They have given you this complete test, right? They have given you the complete test. They have given you the complete test. So you need to imagine your test like this. Then only you can solve this question. Until and unless you do not imagine the test, you would not make this question, right? So empty crucible, water sample, then you kept it in an oven. This oven will make all the water evaporate. All the water will evaporate inside the oven and you are only left with the total solids. Now what you would do is, you with this total solid and the crucible, you place this inside the muffle furnace. You have placed this crucible with the total solids. This is your total solids with the crucible. This is your total solid with the crucible and you have placed this inside the muffle furnace. You have placed this inside the muffle furnace. This is your muffle furnace. This is your muffle furnace. You placed it inside the muffle furnace as at 600 degrees Celsius for the duration of 2 hours. Now what will happen? At such a high temperature, all the organic fraction of this total solid will going to evaporate. All the organic fraction of this total solid will going to volatilize and will going to evaporate. This is the organic fraction. Organic fraction of the total solid, the organic fraction of the total solid will going to vaporize. Now you are left with only the fixed solids. Now when you take out this crucible outside the muffle furnace, you have only the fixed solids. You will only have the fixed solids. You will only going to have the fixed solids. Now these are your fixed solids. These are only your fixed solids, right? All the organic fraction have vaporized. This is your fixed solids. So weight of crucible with the fixed solids, this is given to you. So weight of crucible with the fixed solid is given to you as 60.02 grams. This is given to you as 60.02 grams. Now the question is asking you to calculate what is the organic fraction of the total solid. Such an easy question. The only thing is you need to imagine the process. The process is very important. The process is going like this. From here to here, then from here to here, and then from here to here. Process is very important. Every time you will get a question from this domain, process will be very, very important, right? So this is the process. Now what you have to do is, first of all, you need to calculate quantity of total solids. Quantity of total solids will be total solid plus crucible minus empty weight of the crucible. So quantity of total solids is, so total solids is weight of total solid and the crucible, which is 61.89. So 61.89 gram, right? Minus empty weight of the crucible, which is 58.68. Minus empty weight of the crucible, which is 58.68. Now this much amount of total solid will be present in 50 ml of the sample. The volume of the sample is given as 50 ml. This much amount of the total solid is present in 50 ml of the sample. So divide by 50, multiply by 1000, and this will be now the concentration of the total solid, which will come out in milligram per liter. Just do this. This will be how much? 61.89 minus 58.68 divided by 50 into 1000. So this will be 64.2 milligram per liter. This will be 64.2 milligram per liter. This is the quantity of your total solids. Now next is, you need to calculate the quantity of fixed solids. Fixed solids is equals to weight of fixed solid plus crucible minus empty weight of the crucible. So quantity of fixed solid is, weight of fixed solid plus crucible, which is 60.02. So this is 60.02 minus empty weight of the crucible, which is 58.68. Now this much amount of fixed solid is present in 50 ml of the sample. So divide by 50, multiply by 1000. So this will going to give me the concentration of fixed solids in, again in milligram per liter. Just do this. So this is 60.02 minus 58.68 divided by 50 multiplied by 1000. So this will be 26.8. This will be 26.8. This will be 26.8 milligram per liter. Now we know that total solid is equal to organic solid plus fixed solid. So I'll write like this. Total solid is equal to organic solid plus fixed solids. Total solids is equal to organic solid plus fixed solid. Organic solid plus fixed solids. Organic solid plus fixed solids, right? Total solids you already know. Total solid is 64.2. Total solid is 64.2. Organic solids you need to calculate plus fixed solid. Fixed solid is 26.8. Okay, so you just subtract this 64.2. 64.2 minus 26.8. So this will be 37.4. So organic solid will be 36.4 milligram per liter. This is your quantity of organic solid, but in the question this is not asked. You are asked to calculate the fraction of organic solid. So fraction of organic solid is fraction of organic solid is organic solid divided by your total solid. This is your fraction of organic solid. Organic solid is 36.4. So this is 36.4. Total solid is how much? Total solid is 64.2. Total solid is 64.2. Divide this 36.4. This is 36 or 37.4. Okay, just 1 second. Let me check. 64.2 minus 26.8. This is 37.4. This is 37.4. This is 37.4. So this is also 37.4. 37.4 divided by 64.2. So this will be 0.58, 0.583. This is the organic fraction of total solids. This was asked in the question that organic fraction of total solid will be 0.583, which is my final answer. Okay, I hope you understood this. Chalo, moving on with this. Next, you have this question. Try this and get me the answer. Please comment your answer. Try this, try this. It's a very good question. Try this. This type of statement type question can be framed from those properties. Okay, the question is saying that which of the following statement is correct. You need to identify the correct statement. Okay, every time you should read the question properly, because whether correct or incorrect, you need to identify that. So in this question, you need to identify which of the following statement is correct. First thing, first statement, turbidity is quantitatively related with the concentration of suspended solids. My dear students, now you need to understand this. Turbidity is caused by suspended solids, but turbidity is not related quantitatively with the suspended solids. How it is defined or how it is explained, just observe this. These are the two samples in front of you which contain same concentration of suspended solids. This is my sample 1. Concentration of suspended solid is x milligram per liter. And here also it is x milligram per liter. Concentration of suspended solid is x milligram per liter, and here also it is x milligram per liter. But in the first sample, the size of suspended solids is huge. Size of suspended solid is huge, right? Like this. But in the other sample, the size of suspended solid is small. The size of suspended solid is small. So first of all, you need to understand what is turbidity. The amount by which the light is either scattered or absorbed by the water or by the suspended solids present in the water is termed as turbidity of the water sample. The amount by which the light is either scattered or absorbed is termed as turbidity of the water sample. So if a light ray fall over this suspended solid, it will going to scatter like this. If a light ray falls over the suspended solids, it will going to scatter like this, right? Similarly, if a light ray falls over the suspended solids, it will going to scatter like this. So scattering of light or absorption of light is a surface phenomena. Okay, whatever I am saying, please note this down, very important. Scattering or absorption of light. Scattering or absorption of light. Scattering and absorption of light is the surface phenomena. Scattering and absorption of light is a surface phenomena. It depends on the surface area. It depends on the surface area of the suspended solids. It depends on the surface area of the suspended solids. And we know that if the size of the suspended solid is less, surface area will be less. Sorry, if size of the suspended solid is less, surface area will be more. More the surface area, more will be the scattering of light. So in spite of the concentration being same, the turbidity caused by finer solids will be more. The turbidity caused by these solids will be more. Here the turbidity will be more, the scattering of light will be more. The scattering of light will be more. Here you will observe huge amount of scattering of light like this. Huge scattering of light will be observed if the size of the particle is less. Huge scattering of light is observed like this, right? Huge scattering of light is observed. Even the concentration of suspended solids is same. Still, if the size of the suspended solid is small, it will cause more scattering of light and more will be the turbidity of the water sample. So for this case, here turbidity will be more. Here turbidity will be more. Turbidity will be more. Here turbidity will be more and here turbidity will be less. Here turbidity will be less. Turbidity will be less. Will be less. So with the same quantity of suspended solids, we are getting two different turbidities. Okay. So this is what we say that turbidity cannot be related quantitatively with the suspended solid. Means I cannot say definitely that X milligram per liter of suspended solids will cause Y NTU of turbidity. I cannot say this, that X milligram of suspended solids will cause Y NTU of turbidity. There can be a possibility that same X milligram of suspended solids can cause a range of turbidity depending on the size of the suspended solids. If the size of the suspended solid is more, turbidity caused will be less. If size of suspended solid is less, turbidity caused will be more. So we cannot relate quantitatively suspended solids with the turbidity. So statement A is totally incorrect. Statement A is incorrect. Turbidity cannot be related quantitatively with the suspended solids, right? This is your incorrect statement. Second, true color is caused by the suspended solids and dissolved solids. My dear student, this statement is also incorrect. True color is caused by only dissolved solids. Apparent color is caused by suspended solids and dissolved solids. So the color caused by suspended solids and dissolved solids is known as apparent color. Color caused by suspended solids and dissolved solids is known as apparent color. Color caused by only dissolved solid is known as true color. Right? So this statement is also incorrect. Next, the permissible limit of taste and odor is 1 ton. So 1 ton. So this statement is absolutely correct. We have already seen that the permissible limit of your taste and odor is 1 ton. Next, water extracted underground from underground water source is treated for both suspended solids and dissolved solids. Again, my dear students, you need to understand this. If I talk about the underground water, say this is my ground level. This is my ground level, right? This is my ground level. Okay. From this ground level, the water will seep through the interconnecting voids. The water will seep through the interconnecting voids like this. From this ground level, the water will seep or penetrate through the interconnecting voids like this, right? The water will seep or penetrate through the interconnecting voids to reach the groundwater table. To reach the groundwater table from where this water is extracted. While the water is seeping through the ground, it undergoes natural filtration. It undergoes natural filtration. While the water is seeping or percolating through the ground to reach the groundwater table, it undergoes natural filtration. And this natural filtration removes all the suspended solids which are present in the water. This natural filtration removes all the suspended solids. It removes all the suspended solids. It removes all the suspended solids present in the water. It removes all the suspended solids present in the water. Now water which reaches to the groundwater table, this water only contains the dissolved solids. This water only contains dissolved solids. This water will only contain dissolved solids. This water will only contain dissolved solids, right? So if I extract this water will be only treated for dissolved solids, because while this water was percolating through the ground, it will undergo natural purification that removes all the suspended solids. So this water will be free from the suspended solids and it will only contain the dissolved solids, right? So whichever water if we are extracting the underground water, for this water we need to give treatment only with respect to the dissolved solids, because suspended solids would not be present. So this statement is also absolutely incorrect, because underground water does not contain suspended solids, it only contains dissolved solids. So for this question, only your statement C is the correct statement. Chalo, moving on with this. Next, okay. So this finishes your physical water quality parameter. Just give me 1 second. Meanwhile, you can just note this down. I'll be back in 1 second. Next is your chemical water quality parameters. My dear students, those water quality parameters which affects the chemical quality of water are termed as chemical water quality parameters. Okay, the first chemical water quality parameter is dissolved solids, right? Here it is written total solids. I don't know why there is a printing mistake. Here should be dissolved solids. This should be dissolved solids. This should be dissolved solids, right? So the first chemical water quality parameter is your dissolved solids. Now for measuring dissolved solids, we take the help of total solids, right? Whatever technique we use to measure total solids, suspended solids, using that only we measure the dissolved solids. Again, dissolved solids is measured by gravimetric technique, and the permissible limit of total solid, this is the permissible limit of total solid. This is the permissible limit of total solid. The permissible limit of total solid is 500 milligram per liter. This is your permissible limit for total solid, right? Next one is the alkalinity. What is alkalinity? The acid neutralizing tendency of water is termed as alkalinity. So alkalinity is the property of the anions present in the medium. Alkalinity is the property of the anions. What are anions? Anions are negatively charged particles. Only negatively charged particle can neutralize the H plus ions or the acids present in the water sample. So what is alkalinity? Alkalinity is the acid neutralizing capacity of the water. Alkalinity is caused by the anions present in the medium, right? Majorly you have three types of alkalinity. Caustic alkalinity caused by OH minus ion. Second is carbonate alkalinity caused by CO3 2 minus ions. And third one is bicarbonate alkalinity caused by HCO3 minus ions, right? Alkalinity is measured by titration. The indicators that we used is phenolphthalein and methyl orange. Phenolphthalein is used to measure caustic alkalinity and half of carbonate alkalinity, whereas methyl orange is used to measure another half of carbonate alkalinity and bicarbonate alkalinity. The titrant that we used is 0.02 normal H2SO4. Complete titration is there, right? Next, the permissible limit of alkalinity is 200 milligram per liter as CaCO3. Next one is your pH. Okay, what is pH? pH is a scale to measure acidity or basicity of the water, right? For water sample, the pH should be 7 to 8.5 and this pH is measured using potentiometer using calomel electrodes. Now what is the special thing about calomel electrodes? These electrodes are only sensitive for H plus and OH minus ions. These calomel electrodes are sensitive only for H plus and OH minus ions, right? Next one, you have hardness. Okay, so hardness is caused by the multivalent cations. What are multivalent cations? Those cations or positively charged ions which contains +2 or +3 charge. Example is calcium ions. Example is calcium ions, magnesium ions, right? All these are multivalent cations. Majorly we calculate the alkalinity only because of calcium and magnesium because these are your multivalent cations, right? In general, if you ask me which ions causes the hardness of water, so hardness is caused by the multivalent cations, right? Now what does hardness does to your water, right? What hardness increases your soap consumption. That is one of the major drawback of hardness. Second, hardness leads to the incrustation in the pipes, okay? So that can be the another drawback for hardness. Next one is your chloride content, okay? Hardness is again measured using titration and the indicator that we used is Erichrome black tea with a titrant of EDTA 0.01 normal. So titrant used is 0.01 normal EDTA and the indicator used is Erichrome black tea. The permissible limit of hardness in raw water is, for drinking water is not raw water. The permissible limit of hardness for drinking water is 75 to 115 milligram per liter as CaCO3. This is your hardness, right? Next one is you have chloride content. So chloride content is again measured using titration and here the titrant used is silver nitrate and the indicator is potassium chromate. And this method is also known as Moore's method. The permissible limit of chloride in drinking water is 200 milligram per liter, right? Next, you have the fluoride content. Now fluoride is one of the very amazing parameter. Up to 1 milligram of fluoride is required to protect your teeth or for the proper growth of permanent teeth. Up to 1 milligram per liter of fluoride is required for the permanent growth of your teeth, for the proper growth of your permanent teeth. But if the same fluoride content exceeds 1.5 milligram per liter, it leads to the mottling of teeth or the decolorization of teeth. If your fluoride content exceeds 5 milligram per liter, it leads to a disease which is called as bone fluorosis, right? So the permissible limit of fluoride in your water sample is from 1 to 1.5 milligram per liter. Fluoride is again measured by color matching technique and the color is developed by zirconium ion and alizarin. Permissible limit I have already told you 1 to 1.5 milligram per liter. One second. Next chemical quality parameter is your nitrogen content. So nitrogen can be present in 4 different forms. First one is your free ammonia. So for calculating the free ammonia, you have to simply boil the sample and calculate the quantity of ammonia which is liberated. Second one is your organic ammonia. Organic ammonia is the molecular bonded ammonia present in your water sample. Usually this type of ammonia is double or triple bonded inside your organic matter. So for liberating this ammonia, you need to add a strong oxidizing agent and then you have to boil the already boiled sample. So this free ammonia and organic ammonia is combinedly known as Zeldal's ammonia. Next one is your nitrite. Nitrite is one of the very dangerous substance present in your raw water. If you are consuming a water which contains nitrite, it means that you are inviting different diseases. If nitrite is present in your water sample, it indicates that partially decomposed organic matter is present in your water sample. The presence of nitrite indicates that the decomposition is still going on. The decomposition of the organic matter in your water sample is not complete. Your organic matter is partially decomposed. So the presence of nitrite indicates the partially decomposed organic matter. If this water is consumed, it leads to the waterborne diseases. That's why the permissible limit of nitrite is 0 milligram per liter. The last form in which the nitrogen can be present in your water sample is in the form of nitrate. Now nitrate is the stable end product of the aerobic decomposition. If nitrate is present, it indicates the complete decomposition of the organic matter, right? This nitrate, okay, this nitrate, if you consume water, nitrate will cause no harm to you. Now, if the quantity of nitrate exceeds 45 milligram per liter in your drinking water, and this water is consumed by infants, then what happens is, there is one acid present in the intestine of these infants, and this acid converts nitrate into nitrite, and this nitrite has a strong affinity towards hemoglobin, which is the oxygen carrier, right? And this nitrite starts replacing the oxygen molecule from the hemoglobin, which leads to the deficiency of oxygen into the newborn babies and leads to a disease called methymoglobemia or blue baby disease. So if a question comes in the examination, excess of which substance causes blue baby disease? So this is nitrate. If the quantity of nitrate exceeds 45 milligram per liter and if this water is consumed by an infant, then it leads to blue baby disease. Nitrite and nitrate both are measured by color matching technique. For nitrate, the color is developed by sulfonic acid and naphthamine, whereas for nitrate, the color is developed by disulfonic acid and potassium hydroxide. The permissible limit for nitrite is 0 and for nitrate it is 45 milligram per liter. Okay, chalo, solve this question. It's a very good question. I'll give you 2 minutes of time. Go for it. You have 2 minutes, just do this. It's a GATE previous year question asked for 1 mark. Just do it. Let's see this. Question says a 170 milligram of HNO3 strong acid is added to water, bringing the final volume to 1 liter. So in 1 liter of water, you have added 170 milligram of HNO3. In 1 liter of water, you have added 170 milligram of HNO3. Okay. Consider the atomic weight of hydrogen, nitrogen, oxygen as 1 gram per mole, 14 gram per mole and 16 gram per mole. The pH of the water is, you need to find out pH of the water. Okay, first of all, pH is equal to negative log of H plus ion concentration, and here the H plus ion concentration is reported in moles per liter. It is substituted in moles per liter. Okay. Now if anyhow I can calculate how many moles of hydrogen atoms are present in 170 milligram of HNO3, then I have to just substitute the value, because this 170 milligram of HNO3 is dissolved in 1 liter of the water. So concentration is already in milligram per liter. So I will write down like this. I will write like this. So HNO3 dissociates into H plus ion plus NO3 2 minus ion plus NO3 minus ion, right? This is the dissociation equation for HNO3. Now what I will write, 1 mole of HNO3, 1 mole of HNO3 gives 1 mole of H plus ions. It gives 1 mole of H plus ions, right? Now I have to calculate the number of moles of HNO3. So the given weight of HNO3 is how much? It is 170 milligram per liter, I think. The given weight of HNO3 is how much? The given weight is 170 milligram per liter. So number of moles of HNO3, number of moles of HNO3 is equal to given weight of HNO3, given weight of HNO3 divided by the molecular weight of HNO3, given weight divided by the molecular weight of HNO3. Given weight is 170 milligram. So 170 into 10 raised power minus 3. So this will be in gram, divided by the molecular weight of HNO3 that I need to calculate. Hydrogen is 1, nitrogen is 14, oxygen is 16 into 3. So this is the molecular weight of HNO3 in grams, right? So you need to just divide this to get the number of moles. Do this. So this will be 15 plus 48. 15 plus 48, 63. So this will be 170 by 63, 170 by 63 into 10 raised power minus 3. So these are the number of moles of HNO3. So if 1 mole of HNO3 gives 1 mole of H plus ions, then this many moles of HNO3 will give the same moles of H plus ions. So number of moles of H plus ions, number of moles of H plus ions, number of moles of H plus ion is 170 by 63 into 10 raised power minus 3, right? Now these many moles of H plus ions are dissolved in 1 liter of the water. So here the concentration is in moles per liter only. This is moles per liter only, right? So H plus ion concentration is 170 by 63 into 10 raised power minus 3 moles per liter. Moles per liter, right? Now I got the concentration, I can calculate the pH. So pH is negative log of H plus ion concentration. So negative log of 170 divided by 63 into 10 raised power minus 3, right? This is log to the base 10, by the way, log. Chalo. Now in order to solve this, most of the students have the confusion in this also. So say this is A, this is B. So you have log of A into B. So log of A into B is log A plus log B. If I have to write like this, you remember this property, log of A into B is equal to log A plus log B. log A plus log B. Next, if you have log is to the base 10 of 10 raised to the power n, right? Log to the base 10 of 10 raised to the power n, this is equal to n times of log to the base 10 of 10. Now log to the base 10 of 10, this will be equal to 1 and this comes out to be n. So these two properties you can remember to solve this question. Now solve this one. So you have pH minus log of 170 by 63 minus log of 10 raised to the power minus 3, right? So this is your base 10 only. Solve this to get the value of pH. So this will be minus 3 will come out, so that will be plus 3. So plus 3 minus log of this. So 170 divided by 63, natural log of this. Okay, so 3 minus answer. So this will be 2.659. So pH will be 2.659. This is your pH of your water sample. Few options are given to us. Let's check. 2.659. So 2.67 you can answer. This option D is your correct option. 2.67. Chalo, try this one also. Again, I'll give you 2 minutes of time. Go for it. Let's see the next question. Question says that the alkalinity and hardness of the water sample are 300 milligram per liter and 400 milligram per liter as CaCO3. The concentration of carbonate hardness and non-carbonate hardness as CaCO3 in the water sample is. Now for solving this type of question, you should remember one note point. What does that note point says? So I'll write like this: note, minimum of total hardness, or alkalinity minimum of total hardness or alkalinity is equal to the carbonate hardness. Minimum of total hardness and alkalinity or alkalinity. Minimum value of total hardness or alkalinity is equal to the carbonate hardness, right? In this question, you are given with alkalinity is given as 300 milligram per liter. Alkalinity is 300 milligram per liter. And total hardness is 400 milligram per liter. Total hardness is 400 milligram per liter, right? And you need to find out the value of carbonate and non-carbonate hardness, okay? Alkalinity is 300 milligram per liter as CaCO3 and total hardness is 400 milligram per liter as CaCO3. Now, first of all, carbonate hardness is the minimum of alkalinity or the total hardness. So, minimum is alkalinity, so carbonate hardness will be equal to 300 milligram per liter as CaCO3. So, carbonate hardness will be 300 milligram per liter. Now, non-carbonate hardness can be calculated as total hardness is equal to carbonate hardness plus non-carbonate hardness. Total hardness is 400, carbonate hardness is 300, non-carbonate hardness can be calculated from here. So, non-carbonate hardness will come out as 100 milligram per liter. This non-carbonate hardness will come out as 100 milligram per liter as CaCO3. This non-carbonate hardness will come out as 100 milligram per liter as CaCO3. So, your carbonate hardness is 300 and non-carbonate hardness is 100. So, for this question, your option number D is correct option. Please keep the check of the sequence, in which sequence you need to report. Okay, most of the students, they get confused here. So, first you have to report the carbonate hardness, then non-carbonate hardness. So, this is 300 and 100. Okay, moving on with this. Now, try this question. I'll set the timer for 2 minutes for you. This time you take 3 minutes, no problem. Just go for this question. Okay, let's see this question. The question says that the water sample contains following dissolved ions. You have sodium ion, calcium ion, magnesium ions and aluminium ions. Then you have bicarbonate ion and chloride ion. Atomic weight is given to you. You need to calculate the total hardness and the non-carbonate hardness of the water sample. Okay. Now my dear students, again I would like to tell you here, for calculating this non-carbonate hardness, you require carbonate hardness. For calculating carbonate hardness, you require alkalinity and total hardness, both. Okay. Now for calculating total hardness, you will only consider these major ions, calcium and magnesium, right? You will going to calculate the total hardness caused by the major ions, and major ions are calcium and magnesium. Now how to calculate the total hardness? Total hardness is equal to number of gram equivalents of calcium ion plus number of gram equivalents of magnesium ion multiplied by the equivalent weight of CaCO3. So I'll write like this: total hardness is equal to number of gram equivalents of calcium ion plus magnesium ion, number of gram equivalents of calcium ion plus magnesium ions multiplied by the equivalent weight of CaCO3 multiplied by the equivalent weight of CaCO3 multiplied by the equivalent weight of CaCO3. This is how we calculate the total hardness. Now observe this. Number of gram equivalents of calcium ion is equal to number of gram equivalents of calcium ions. Number of gram equivalents of calcium ion is equal to the given weight of calcium ion is equal to the given weight of calcium ion divided by the equivalent weight of calcium ion divided by the equivalent weight of calcium ion. Okay, I am writing down everything step by step so that you have full clarity how we are solving this, right? Most of the student, when the moment they see chemistry in the exam, they feel like, oh, leave the question. These are one of the very easy questions that you should never leave. Whenever they see, oh, ions, this and that, they start leaving the question. They don't even read the question. And I'll solve this question in front of you and you will realize how easy these questions are. First, I have written total hardness is equal to number of gram equivalents of calcium and magnesium ions multiplied by the equivalent weight of CaCO3. I am writing everything. Number of gram equivalents of calcium is equal to the given weight of calcium divided by the equivalent weight of calcium. Now, the given weight of calcium is how much? It is already given to us. The given weight of calcium is 50 milligram per liter. So I will write down 50 into 10 raised to power minus 3. Okay. I am calculating gram equivalence. So if the quantity is given in milligram per liter, so I will write down 10 raised to power minus 3 to convert this into grams, right? Because the equivalent weight that I will substitute will be in grams only. So this is 50 into 10 raised to power minus 3. Now equivalent weight of calcium is the atomic weight of calcium. What is the atomic weight of calcium? 40 divided by the valency of calcium. Okay, for now we need not to go into that much depth of chemistry that we read in 11th or 12th class and the methods of figure out the valency. Okay, valency is a very complicated term. First of all, you need not to worry about that. Right now for us, valency will be either 1 or it will be 2. You have to just see the charge present over the ions. Whatever is the charge present over the ion, that will be the valency for us. We need not to go into the depth of valency that we read in 11th or 12th class. That is, okay, valency is defined as the number of electrons for which the number of electron exchange for which the reaction happened. That is defined as your valency, right? Right now for us, valency is just the charge present over the ion. Here calcium is +2 charge. So the valency for calcium will be 2. So molecular weight of calcium is 40 divided by the valency of calcium, which is 2. So this is the number of gram equivalents of calcium. Similarly, I'll calculate number of gram equivalents of magnesium. Number of gram equivalents of magnesium 2 plus. So this is equal to the given weight of magnesium. It is equal to the given weight of magnesium Mg2 plus divided by the equivalent weight of magnesium divided by the equivalent weight of magnesium, right? What is the given weight of magnesium? The given weight of magnesium is 48 milligram per liter. So I'll write like this. This is 48 into 10 raised power minus 3 divided by the equivalent weight of magnesium. So equivalent weight of magnesium is the molecular weight of magnesium, which is 24, divided by the valency of magnesium, so 2. So 24 is the atomic weight divided by the valency of magnesium, which is 2, right? These are the number of gram equivalents of calcium and magnesium. Now equivalent weight of CaCO3, you understand this also. Equivalent weight of CaCO3 is equal to the molecular weight of CaCO3 divided by the valency of CaCO3 Okay, so when you calculate the molecular weight of CaCO3, calcium is 40, carbon is 12, oxygen is 16 into 3. So 40 plus 12 plus 48, this will come out as 100. So molecular weight of CaCO3 is 100. Now valency of CaCO3, you have to observe this. Ca is 2 ions deficient and CO3 has 2 ions in excess. So the formation of CaCO3 takes place through the exchange of 2 ions. So the valency of CaCO3 is also 2. The valency of CaCO3 is also 2. So equivalent weight of CaCO3 is 50 milligram per liter, right? Now you know number of gram equivalents of calcium, you know number of gram equivalents of magnesium, and you also know the equivalent weight of CaCO3. You can calculate the total hardness. So total hardness is equal to, so this is 50 into 10 raised power minus 3 divided by 20. 40 by 2 is 20, right? Plus 48 into 10 raised power minus 3 divided by 24 by 2 is 12 into 50. Now this will going to give me the concentration in gram per liter as CaCO3. You take out this 10 raised power minus 3 common and multiply it with gram. So this will be milligram per liter, right? So you have 50 by 20 plus 48 by 12 multiplied by 50. So you have 50 by 20 plus 48 by 12 multiplied by 50. Now this will going to give me the answer of total hardness in milligram per liter as CaCO3. Just solve this. So this is 50 by 20. 50 divided by 20 plus, this is 12 fours are 48 plus 4 into 50. So this comes out as 325 milligram per liter as CaCO3. I'll write here. Total hardness is 325 milligram per liter as CaCO3. This is your total hardness. 325 milligram per liter as CaCO3. This is your total hardness, right? Now this is the first thing that you have calculated, total hardness. Next is you need to calculate the alkalinity. Now my dear students, for calculating the alkalinity, again you will only consider the major ions. What are major ions? HCO3 minus ion. This HCO3 minus ion is the only major ion that will cause the alkalinity. Okay, now this is This is, even I don't know why they do not consider this, but while if they are expecting us to calculate alkalinity and hardness, they only want the calculation of the major ions. The major ions which cause alkalinity is OH minus ions, HCO3 minus ions and CO3 2 minus ions. So here I need to calculate alkalinity only because of this HCO3 minus ions. So please do it. So alkalinity is equal to number of gram equivalents of HCO3 minus ion into equivalent weight of CaCO3. Into equivalent weight of CaCO3, right? Now the number of gram equivalents of HCO3 minus ion is equal to the given weight of HCO3 minus ion, divided by the equivalent weight of HCO3 minus ion. Equivalent weight of HCO3 minus ion. Okay. This will be the number of gram equivalents of HCO3 minus ion multiplied by the equivalent weight of CaCO3, which is 50 gram per liter. Right? Now the given weight of HCO3 minus ion is how much? It is 122 milligram per liter. So I will write down 122 into 10 raised power minus 3. Equivalent weight of HCO3 minus ion is the molecular weight of HCO3 minus ion. So hydrogen 1, carbon 12 and oxygen is 16 into 3, 48. 48 plus 12 is 60, 60 plus 1 is 61. 61 is the molecular weight and valency of HCO3 is 1. You can see just one charge, right? So valency is 1. Multiplied by 50 and this will give me the alkalinity in gram per liter as CaCO3. This will give me the alkalinity in gram per liter as CaCO3. Again, this 10 raised power minus 3 in gram will be milligram. So just do this, 121, this is 122, this is 1 times, this is 2 times. And 2 into 50 is 100. So alkalinity will be 100 milligram per liter as CaCO3. This is your alkalinity of the water sample. This is your alkalinity of the water sample, right? Now you know the alkalinity of the water sample, you know the total hardness of the water sample, you can calculate the carbonate hardness. So total hardness is 325 milligram per liter. Total hardness is 325 milligram per liter as CaCO3. Now using these two data you can calculate the carbonate hardness. The minimum of total hardness and alkalinity is equal to the carbonate hardness. So carbonate hardness is minimum of total hardness or alkalinity. Minimum of total hardness or alkalinity. Minimum of total hardness or alkalinity is equal to the carbonate hardness. Now from here the value of carbonate hardness will come out as alkalinity is 100 and carbonate hardness is 325. So obviously carbonate hardness will be 100 milligram per liter as CaCO3. Once you know the carbonate hardness, you can calculate the non-carbonate hardness. So total hardness is equal to carbonate hardness plus non-carbonate hardness. Total hardness is 325. Carbonate hardness is 100. Here you can calculate the non-carbonate hardness. So non-carbonate hardness will come out as non-carbonate hardness will come out as 225 milligram per liter as CaCO3. 225 milligram per liter as CaCO3. This is your non-carbonate hardness. 225 milligram per liter as CaCO3. Again, a very important question. 225 milligram per liter as CaCO3. Okay, chalo. Moving on with this. Try this one. Try this one. I'll give you 3 minutes of time. Go with this. Do it. It's a very good question. So let's see this question. The question is saying, now this variety of questions are frequently asked in your GATE examination, right? This variety of question is frequently asked in your GATE examination. Question is saying that from the chemical analysis of the water sample, following results were obtained. You have C2H6 20 milligram per liter, CO2 5 milligram per liter, O2 6 milligram per liter, NH3 10 milligram per liter. Calculate the total carbon content in milligram per liter present in the water sample in any form. My dear students, when I talk about these type of questions, now when you see this question, right, the first thing you do is leave it. Don't understood anything, haven't understood anything, leave it. These are one of the easiest question. Now observe this. What you have to calculate? You have to calculate the carbon content right now, okay. First I am going to tell you how to solve this question, and then I am going to tell you the generalized approach, okay. Right now you need to calculate the carbon content. So what you need to do is, whichever compounds which contains carbon, you need to just list them down, okay. So you have C2H6, C2H6 contains carbon and the concentration of C2H6 is 20 milligram per liter. Okay. Second, CO2 contains carbon, so CO2. So concentration of CO2 is 5 milligram per liter. You need to calculate the carbon content. So what you have to do, step 1 is, whichever compound contains carbon, you have to just list them down. That's all, nothing to do. Okay. Now tell me, in the 1 mole of C2H6, 2 moles of carbon is present or not? In 1 mole of C2H6, 2 moles of carbon is present, and in 1 mole of CO2, 1 mole of carbon is present. Okay, this much you can write. Let me write this down. For C2H6, let me take this. For C2H6, 1 mole of C2H6, 1 mole of C2H6 contains 2 moles of carbon. 2 moles of carbon, very simple, one statement. 1 mole of C2H6 contains 2 moles of carbon. The concentration of C2H6 is 20 milligram per liter. This is 20 milligram per liter. So can you calculate number of moles of C2H6? Number of moles of C2H6 is equal to the given weight of C2H6, so 20 milligrams, so 10 raised power minus 3, divided by the molecular weight of C2H6. Given weight of C2H6 divided by the molecular weight. What is the molecular weight? Carbon is 12, so 12 into 2. Carbon is 12, so 12 into 2 plus hydrogen is 1 into 2, right? So these are the number of moles of C2H6. If 1 mole of C2H6 contains 2 moles of carbon, then this many moles of C2H6 contains twice of this quantity of carbon. So I'll write like this, 20 into 10 raised power minus 3 divided by, how much is this? This is 24 plus 2, 26 moles of C2H6 contains 2 into this number, 2 into 20 into 10 raised power minus 3 divided by 26 moles of carbon. So these many moles of carbon are present in C2H6, right? Now next is, you have CO2. What is the concentration of CO2 given? CO2 is 5 milligram per liter. This is 5 milligram per liter. Now from this, can I write down 1 mole of CO2 contains 1 mole of carbon. So 1 mole of CO2 contains 1 mole of carbon. 1 mole of carbon, right? So can I calculate number of moles of CO2? Can I calculate number of moles of CO2? Nirmal is saying something. Okay. So number of moles of CO2 will be, number of moles of CO2 is how much? This is the given weight of CO2, which is 5 milligram per liter. So 5 into 10 raised power minus 3 divided by the molecular weight of CO2. So molecular weight of CO2, carbon is 12, oxygen is 16 into 2, right? This is how much? This is 32. 32 plus 12 is 44. So this will be 5 into 10 raised power minus 3 divided by 44. Now these are the number of moles of CO2. If 1 mole of CO2 contains 1 mole of carbon, then this many moles of CO2 contains this many moles of carbon. So 5 into 10 raised power minus 3 divided by 44 moles of CO2 contains 5 into 10 raised power minus 3 divided by 44 moles of carbon, right? So these are the number of moles of carbon which are present in CO2, and second, these are the number of moles of carbon which is present in C2H6, right? Now you need to just add and find out the total number of moles of carbon present in the water sample. The total number of moles of carbon, total number of moles of carbon, total number of moles of carbon is equal to number of moles of carbon present in C2H6. So this is 2 into 20 into 10 raised power minus 3 divided by 26. These are the number of moles of carbon present in C2H6 plus the number of moles of carbon present in CO2. So this is 5 into 10 raised power minus 3 divided by 44. So these are the total number of moles of carbon which are present in the water sample. Once you get the total number of moles of carbon, for calculating the carbon content, you have to just multiply it with the atomic weight of carbon. That's all. So carbon content is equal to carbon content is equal to number of moles of carbon, multiplied by the atomic weight of carbon, right? So number of moles of carbon, clearly I know this is 2 into 20 into 10 raised power minus 3 divided by 26 plus 5 into 10 raised power minus 3 divided by 44. These are the number of moles of carbon multiplied by the atomic weight of carbon. So remember, atomic weight of carbon is 12 gram, right? 12 gram. And this concentration is in per liter. So here the carbon content you will get in gram per liter, right? You can take out this 10 raised power minus 3 common, and when you combine this 10 raised power minus 3 with gram, it will be milligram. So you can solve this expression to get the carbon content in milligram per liter. Just do it. So this will be 40 by 26 or 20 by 13. 20 by 13 plus 5 by 44. 20 by 13 plus 5 by 44 multiplied by 12. So this will be 3.21 milligram per liter. This is your carbon content. This is your carbon content, 3.21 milligram per liter, right? So whenever you get a question from carbon content, first of all, write down all the compounds which contains carbon. Step 2, calculate the number of moles of carbon present in all the compounds. Third, calculate the total number of moles of carbon, and once you have the total number of moles of carbon, you multiply it with the atomic weight of carbon to get the carbon content, right? Now this is just one variety of question where carbon content is asked. For suppose you are asked to calculate nitrogen content, then for any content, okay, now this is my general approach. For any content, this is my general approach to solve these questions. For any content, it can be nitrogen content, carbon content, oxygen content, fluoride content, chloride content, any content, any content, okay. Sir, what I am trying to say is for C2H6 the value is 30 or 26. 30, why 30? This carbon is 12, okay. Oh, okay, correct. This is 6, right? This is 6, very good. Thank you so much. This is 30. Okay, just correct this. So this is also 30. This is also 30. This is also 30 and the answer will change here. Thank you so much, my dear. This is 30. This is also 30. Please tell me the answer for this also. Can you tell me the answer for this? Thank you so much, Nikhil. Just in too much of excitement, even I made these kind of mistakes, calculating 2 hydrogen instead of 6 hydrogen. Okay. Thank you so much, Nikhil. Once again, thank you so much. This is 20 into 10 raised to power minus 3 divided by 30. Okay. You have 6 hydrogen atoms, right? Chalo. So, please correct your answer here. So, this will be 2 into 20. So, 4 by 3 plus 5 by 44. So, 4 by 3 plus 5 by 44 multiplied by 12. So, this will be 17.36. This will be 17.36 milligram per liter. Okay. Now, observe this. Chalo, this is the small correction we had. Now, I am talking about the general approach for any content. If you are given with any content, say any element, nitrogen, carbon, oxygen, fluoride, chloride, any content, any. What you have to do, step 1 is any content. I'll name this as content X just to generalize, right? Just to generalize. For any content, step 1, list down all the compounds containing X. List down all the compound containing X, right? Step 2, calculate number of moles of X. Calculate number of moles of X present in individual compounds. Present in individual compounds. Present in individual compound. What is the quantity of X present in compound 1, compound 2, like that? You calculate the quantity of X, number of moles of X present in individual compound. Step 3, calculate total number of moles. Calculate total number of moles. Calculate total number of moles. Moles of X by adding calculate total number of moles of X by adding. Step 4, content of X or X content. Content of X or X content is equal to total number of moles of X. Total number of moles of X. Total number of moles of X multiplied by the atomic weight of X. Multiplied by the atomic weight of X. Okay. Now, if X is nitrogen content, you have to list down all the compound that contains nitrogen. Then you need to calculate number of moles of nitrogen present in all the compounds, and then you have to add all the number of moles of nitrogen to get the total number of moles. Once you have the total number of moles of nitrogen, you need to multiply it with the atomic weight of nitrogen to get the nitrogen content, right? As simple as that. Now, what a check you need to keep? In which units the quantity of different compounds are there. If they are in milligram per liter, accordingly you need to keep a check on that, right? So, this is just a 4-step approach for calculating the any content. Any, it can be nitrogen, carbon, and the best part is from last 2-3 years we are regularly seeing question from this concept. Okay, so you can just note these steps down. These are very, very important steps. You can just note these steps down. These are very important steps. Okay, so we will going to just pause here itself, right? So this is what we have discussed in this session. Tomorrow we have a session from 4 p.m. onwards. From 4 to 7 we will going to discuss the remaining parts of environmental engineering, and we will also going to discuss the questions. And my focus will be discussing the concept using the question. I hope today you have enjoyed so many concepts and you have revised such a huge quantity of your concepts in just a span of 3 hours. Okay. So this is all for today. Tomorrow I'll see you on the same YouTube channel at 4 p.m. onwards with the second session of environmental engineering. So this is all from my side today. Have a very great night ahead. Thank you so much.